In the previous video, we saw how to balance redox reactions in acidic solution. In this video, we're going to balance a redox reaction in basic solution. And these are a little bit harder, but we're going to approach it the same way that we balanced the reactions in the acidic solution. So we're going to, once again, step 4, add some protons here. And we're going to go ahead and add the half reactions together, but after we do that, we're actually going to add some hydroxide anions in here as well. Since this takes place in basic solution, the hydroxide ions are necessary to neutralize the protons that we added in step 4. And so let's start off by starting with oxidation states, right? Just like we did in the previous video. So if I start with the hypochlorite anion here, I know that oxygen has an oxidation state of -2. I know the total has to equal -1 here, so that means that chlorine must have an oxidation state of +1. +1 and -2 give you -1. If I go to this chromium compound over here, the easiest way to approach it is to remember that the hydroxide anion has a charge of -1, and you have 4 of them, giving you a total of -4. In terms of oxidation states, the total has to add up to equal -1 here, the charge on the ion. Therefore, chromium must have an oxidation state of +3. +3 and -4 give you -1. So chromium's oxidation state is +3 here. Move over here to the right to the chromate anion. So oxygen is -2. I have 4 of them for a total of -8. I need to get a total of -2, the charge on the ion. And so for an oxidation state for chromium, it would be +6, because +6 and -8 give you -2. So chromium's oxidation state is +6 here. And then finally, for the chloride anion, -1 charge, therefore an oxidation state of -1. In terms of what is being oxidized and what is being reduced, you need to look for an increase in the oxidation state for oxidation. So going from an oxidation state of +3 to an oxidation state of +6 for chromium means chromium was oxidized. And if we look at chlorine, right, it's going from an oxidation state of +1 all the way over here to an oxidation state of -1. That's a decrease in the oxidation state, or reduction in the oxidation state. So chlorine is being reduced. And so we know that something is being oxidized and something is being reduced. And so we can go ahead and do step 1 now. We're going to write our half reaction. So one oxidation half reaction and one reduction half reaction. This time let's go ahead and write the reduction half reaction first. It doesn't really matter which one you do. So we'll go ahead and write the one using chlorine, since chlorine was reduced here. So the hypochlorite anion going to the chloride anion here. So this is the reduction half reaction. The oxidation half reaction is the one that involved chromium. So we had this chromium compound, CrOH4, with a negative charge, right, going to chromate, CrO4 2-. So this is our oxidation half reaction. So let's go to step 2. Balance the atoms other than oxygen and hydrogen. So the atoms other than oxygen and hydrogen. So for the reduction half reaction, that applies to chlorine. We have 1 chlorine on the left and we have 1 on the right. So chlorine's balanced. In the oxidation half reaction, that applies to chromium, right? So 1 chromium on the left and 1 chromium on the right. So in this case, step 2 is already done for us. But always be careful, because sometimes you actually have to balance these atoms and it will affect your final answer. So let's go to step 3. Balance the oxygens by adding water. So if we look at our reduction half reaction, we can see there's 1 oxygen on the left side and we have no oxygens on the right side. So we need to add 1 water molecule to the product side of our reduction half reaction. Now we have 1 oxygen on the right and 1 oxygen on the left, and so oxygen is balanced for our reduction half reaction. Let's look at our oxidation half reaction. Remember, this 4 here applies to everything in the parentheses, so we have 4 oxygens on the left and we have 4 oxygens on the right, and so oxygen is already balanced. Next, we go to step 4, balance the hydrogens by adding protons. So if I look at my reduction half reaction, we added a water molecule, right, and that introduced 2 hydrogens on the right side of my half reaction. And so therefore, I need 2 hydrogens on the left side, because right now I don't have any, and I'm going to balance them by adding them in the form of protons. So I have to add 2 protons to the left side of my reduction half reaction, and now I have 2 hydrogens on the left and 2 hydrogens on the right. For my oxidation half reaction, remember this 4 applies to the hydrogen as well, so I have 4 hydrogens on the left and none on the right side of my oxidation half reaction. So I need 4 on the right. I'm going to add those in the form of protons. So 4H plus on the right side. Next, we're going to add electrons to balance charge. So step 5, we need to analyze the total charges on both sides of my half reaction. So let's look at the reduction half reaction first. I have 2 protons, right? So that's 2 positive charges on the left side here. And I also have a negative charge on the hypochlorite anion here. So I have 2 positive charges and 1 negative charge. So of course that's a total of +1. And I have a habit of writing my charges like I have how I write my oxidation states. So just remember that these are charges, not oxidation states. And a total of +1 on the left side, and on the right side, right, I have 1 negative charge on the chloride anion, and that's it in terms of charges. And so I have a -1 charge on the right side here. So I need to get those charges to be equal, and I can only get that by adding electrons, which are of course negatively charged. So if I want to get both sides of my reduction half reaction equal, the only thing I could do is add 2 electrons to the left side right here, because that gives me 2 more negative charges. So that takes this +1 to a -1. So now I have a total of -1 charge on the left side of my half reaction. And that, of course, is now equal to the -1 on the right side of my half reaction. So I have balanced the charges by adding electrons. Let's do the oxidation half reaction now. So I have only one of these ions, so I have a -1 charge on the left side. On the right side, I have 1 chromate, but each chromate has 2 negative charges, like that. And then I also have 4 positive charges for my protons. So -2 plus 4 gives me a total of +2. So I have +2 on the right side and -1 on the left side. So once again, my goal is to balance those charges by adding electrons only. And if I add 3 electrons to the right side of this half reaction, right, I would change this total charge from a +2 to a -1. And so now I have -1 on the right and I have -1 on the left. And so my charges are balanced. Another way to think about where those electrons go, right, is to remember that Leo the lion goes grr, right? So oxidation, Leo, loss of electrons is oxidation. So that's why you have to show your electrons on your oxidation half reaction being lost or given off on the product side, if you will. And then Leo the lion goes grr, so gain of electrons is reduction. So you would have to show the electrons for your reduction half reaction being on your reactant side of your half reaction because they're being gained here. So that's another way just to double check yourself or think about it. So we're on to step 6 now. Make the number of electrons equal. So for step 6, make the number of electrons equal. So the reason you have to do that is because the electrons that are being lost in the oxidation half reaction are the exact same electrons that are being gained in the reduction half reaction. So we had 3 electrons being lost, but only 2 electrons being gained, and that doesn't make any sense, right? They're the same electrons, they should be the same number. And so we need to make those number of electrons equal. And the way to do that, of course, is to think about lowest common denominator. So we have a 2 and a 3. So we can make those 6 electrons. So we need to figure out a way to make both of our half reactions have 6 electrons. And we can do that by multiplying our first half reaction by a factor of 3 and multiplying our second half reaction by a factor of 2. And that will give us equal numbers of electrons. Let's go ahead and do that math here. So let's go ahead and take 3 times 2 electrons, right? That gives me 6 electrons. And then 3 times 2 protons, right? Gives me 6 protons. 3 times the 1, the coefficient in front of the hypochlorite anion, gives me 3ClO minus. The 3 times the 1 in front of the chloride anion gives me 3Cl minus. And then finally, there's a 1 in front of the water as a coefficient as well. So 3 times 1 gives me 3 waters. So let's go ahead and do the oxidation half reaction now. Let's get some more room here. So I take the 2, I multiply it through, there's a coefficient of 1 in front of here, in front of this ion. So now I would have 2Cr parentheses OH4 minus. The 2 applies to the 1 coefficient in front of the chromate as well, right? So I would have 2CrO4 2 minus. The 2 applies, right? 2 times 4 gives me 8 protons, so I have 8 protons here. And then finally 2 times the 3 electrons gives me those 6 electrons. And so now we have 6 electrons for my reduction half reaction and 6 electrons for my oxidation half reaction. Next, we're going to add our half reactions together. So once again, we're still pretending like we are in acid here. So let's go ahead and add our half reactions together. We're going to take all of our reactants, right, and put them on one side. So let's go ahead and do that first. So we have 6 electrons plus 6 protons plus 3ClO minus plus 2Cr parentheses OH 4 minus. And so on the right side, so we take all of this, right, and we add it all together for our product side. All right, so let's see what we have. We have 3Cl minus plus 3H2O plus 2CrO4 2 minus plus 8H plus 6 electrons. So finally, all right, now that we've written that out, I think it's easier to see that you have 6 electrons on the left and 6 electrons on the right, so you can cancel those out. You also have some protons on both sides, right? You have 6 protons here and 8 protons here, so you could cancel out these 6 protons, and you can make this 2 protons on the right side. So let's go ahead and rewrite what we have once again. So let's see what we have now. Now that we've simplified it a little bit, we have 3ClO minus plus 2Cr parentheses OH 4 minus yields 3Cl minus plus 2H2O, 3H2O plus 2CrO4 2 minus plus 2H plus. All right, so now we have to remember that this reaction was actually done in base, right? So we're going to add in some hydroxide anions to neutralize the protons. So if we look at the number of protons we have, right, we have 2 protons over here on the right. So we need to add 2 hydroxide anions. So we're going to add 2 hydroxide anions to neutralize those protons. And since it's a balanced equation, what we do to the right side, we have to do to the left side as well. So since I added 2 hydroxides to the right, I need to add in 2 hydroxides to the left. Now let's think about what adding those hydroxides to those protons will do, right? So they will neutralize each other. If you take H plus and OH minus, you will get H2O. And so we're going to get water molecules, and we're going to get 2 of them since we're neutralizing 2 protons with 2 hydroxide anions. And so actually on the right side, we're going to get 2 H2Os here, so 2 water molecules on the right side. So let's go ahead and write the final answer here, including everything that we've done. So on the left side, we have 3ClO minus plus 2Cr parentheses OH 4 minus, and now we added in those 2 hydroxides, right? So plus 2OH minus, and then on the right side we had 3Cl minus plus, well, over here we have 3 waters, and we just made 2 more, and so we really have a total of 5. So 5H2O, and then once again we have the 2 chromates over here, so 2CrO4 2 minus. And that should take care of everything. So we can go ahead and box our final answer. So we got there. It took us a long time, but we have our final answer. And remember, you can always check your final answer in terms of number of atoms and charge. So both atoms and charge should balance. And so you can go ahead and check this one on your own, just like I showed you how to do it in the previous video.